Hey everybody, this is Larry. This is me going Q3 of the weekly contest 483. Minimum cost to make 2 binary strings equal. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. So this one is really tricky, honestly. To do it fast, to do it correct, or maybe hopefully even both. I don't really have any great insight to this one. Initially, I did think that it was going to be DP. But then I took a look at the constraint is 10 to the 5th, which is going to be too much for an n times m type solution. Not to mention that there's like weird things like distinct and swap, right? The key thing is just noting that because there are operations for each one, there's a flip cost, swap cost, and a cross cost. But what that means is that greedy is going to make sense, right? Meaning that because these operations do not, well, I mean, they're only zeros and ones anyway, but even ignoring that, it does not, there's nothing that changes things for you, right? Meaning that a flip cost is going to be the same whether it's going from 0 to 1 or 1 to 0. Swap cost will always be the same. So in a way, the relative, like the relative value of the cost will always be the same, right? Meaning that in a greedy way, if the flip cost is good, then you do it first and so forth. And once you have that realization, then you can just try to figure out how, what are the moves that you can do. Flip cost, it's very basic. You can do it on anything and it'll always get you one step closer, right? So, you just do the math for this one. Well, I think this one is just literally, you just always flip cost. Swap doesn't really mix. The swap cost has 2 ways to use it, right? One is that if 2 things are out of place, you swap them. Now you have 2 things that are where they want to be. And then the third way, or the second way, is to use this cross cost. The cross cost doesn't make sense to me by itself, right? So, and I was trying to make sense of it by itself, but it doesn't, because if it's incorrect, it'll stay incorrect. The only way you use a cross cost is by you cross it and then you flip it. But if you're going to do that, you could just flip it, so you don't need it. So that's silly. But then you can also do what they tell you in the example, which is do a cross and then swap. That means that if you have 2 ones, then now you get rid of 2 ones at the same time, kind of thing, right? So you could do that for cross and swap at the same time. So those are the 3 things that I considered, and honestly, I just wrote out a lot of enumeration. So we'll go over it real quick. Another thing that you might have to consider, though, is how to represent the different characters. And that is something that you should have to figure out. For me, the way that I did it is just that I consider S and then just transferring into T. Because for all purposes, if they're not the same, it means that T is literally the opposite, right? Meaning if you're 0, T is 1, T is 0, or the other way around, S is 0, or whatever. You get my point, right? It's just that T is the other one. So that means that if you just store S's version of it, it is the same information, right? You don't store any more. And here, yeah, this one, the first try is we flip all the mismatches, right? And this one, hopefully I don't have to explain too much. It is what it sounds like. You have this many ones that are out of place. By the way, I did do a loop of you should be able to read this from me explaining it, but yeah. So these are the ones that are different, zeros that are different, and then just times flip cost, and that's one possible answer. This is why we do a min of them. The next one is doing the cross swap trick that we said about, right? So that means that, yeah, for every 2, for example, if you have 2 ones, then now you could get rid of them by using the swap cross. Or technically you do the cross and then you do the swap, but yeah. So for each pair of 1s and then pairs of 2s, of course, after you do this, you might have leftovers of, right? And this is basically what it does. For the leftovers, then we either just flip them. So if you have 1 leftover, you can flip them. You have 2 leftovers, you can flip them, and you can only have 1 leftover per digit, right? Per 0 or per 1, right? Because you paired everything else. The other thing that you can do is swap, and of course you would only swap if you have 1 1 and 1 0, right? And this is what this if statement does, even though maybe it's not the cleanest code to read. But yeah, but if this is 1 and this is 1, then the total is going to be 2, and it is the only way that is 2, just to be clear. So then you can swap them and that'll be just as good. Otherwise it's infinity, because I mean, you could do like a swap and then a flip or something, but then you just do a flip. So I just don't even want to, like, it's not necessary. So I don't think about it and give it infinity. The other way is prioritizing swap. Keep in mind that the reason why we say prioritize or try these is because everything depends on the swap cost, and flip cost, right? So these numbers would just have different values depending on the cost, even if the string is the same. So yeah, so prioritize swap, that means that if you have the same number or for every pair of zeros and ones that were counted, that means that they're in the wrong place, then that means that you could directly swap them, right? And that means that, well, these are, I put min because this is min, but you could think about them as pairs, right? So you have pairs of numbers, which is the min, right? And yeah. And you can see that per pair, that's the swap cost. So that's all the swap cost. And then extra is just whether you, keeping in mind that this is a maybe awkward way of writing it, but you can really think about this as is equal to SO minus P plus SZ minus P, right? And P, of course, is the min of these. That means that one of them will go to 0, and then the other is just whatever is left over. So that's what extra means, and that's what this formula does. Yeah, and then when you have extra, they're all of the same digit, right? So it's either all zeros or all ones, so there's no swap. Well, you could do a swap cost, but or cross swap, but there's no pure swap. So you can either this is almost like a variation of the first two things that we already done, which is that you could just flip all of them, right? Makes sense. And then the other is just do this swap cost thing, right? Of pairing them up, doing the cross. Maybe I put this in the helper function, but plus if you have any extras, you times it by the flip cost, because you can only have one extra, by the way, of course. One extra, and then you just flip it, right? Yeah, that's it. And then you take the best of all those, and that's it. I mean, I don't think there's anything, I want to say I don't think there's anything tricky about it in the sense of algorithmically, right? There's no crazy algorithms that is tricky. It is just about thinking through every possible case. And I think there is probably... I think now to think about it, maybe you could have write helper function for these, and then that would have made this much cleaner to read and or whatever. But it worked enough. So yeah, that's it. I mean, this other than this linear loop to counter the mismatches, everything is constant. So yeah, that's all I have for this one. Let me know what you think, and you can watch me solve it live in the contest now. I thought about doing some pruning, but I just did the math, that's all, and it wasn't that interesting. Probably even just do a 4 for loops, you don't need recursion if you don't want to. Anyway. I and flip S sub I or T sub I. Oh, okay, so you have two strings, binary. You have to flip one of them, and it's flip cost. It doesn't really matter which one. If you flip, it makes it the same anyway. I mean, this seems like it's just DP. Oh, but it's 10 to the 5th, so maybe I'm wrong. I thought it was going to be like a LCS type thing. Okay, so this one I guess is straightforward, but I didn't keep reading. What's swap? IJ. Again, maybe this doesn't really matter. Oh, but this is binary, that's why. So the swap never really, I don't know. I mean, if it's cheap, then I guess it's good, but I'm confused. When would you ever use this? Cross. I guess you could cross and then swap or something. Is that really the... That just seems complicated. I mean, you can definitely make the cost make sense, I guess, or make that make sense. But how do I think about this? I mean, basically, clearly, you only do something if they're different, right? If they're different, so you can always just flip all of them. So there's always an answer. But flip cost could be high, for example. Swap. What is cross again? Would they ever do cross? I guess you do a cross and then a swap like they did here. You only do a cross and a swap. Alright, I think it just becomes like an enumeration thing. So you can always use a flip to get rid of it. Okay, so flip gets rid of one delta. Swap still doesn't do anything, but no, that's not true. I mean, so you can swap by itself can get rid of two things, two delta. Can also use cross plus swap for two flips, right? Because it just means that you do a cross and then you flip or you swap. Otherwise it doesn't make sense. Otherwise the cross doesn't change anything. You could also do cross. Yeah, because it doesn't make sense to do a cross or flip. So cross basically has to do with a swap, right? And we swap by itself can get rid of two delta, but it depends on the cost, right? So it's just a lot of if statement, but also needs 0 and 1 transposed. Okay, so then now and the actual string doesn't matter. Maybe. No, it doesn't matter because you would never use, because if you only have one character out of place, you would never do any of the other ones because yeah, so then it is just purely on, because if you change something to make it worse, then you have to change it back later. Okay, maybe, right? Oops. Okay, then how do I represent it? I guess we just represent the S version, right? So maybe S1, S. Because by definition, T is the other one. Okay. Okay, so best is equal to infinity. We could set the base case as actually equal to the number of missings times flip cost, right? And then now we can think about optimization. Yeah, okay, so that means that can I just do the cross and swap trick, right? That means that for every pairs of SO and SZ, every pair we swap cost plus cross cost, right? Plus plus then now you have an extra one of these maybe. So you have extra of these, and then you get rid of them either by flipping or a swap if you have one of the other, but that's so annoying to write. How do I even write that? So okay, infinity if this is equal to 0, that means that they're both 0. They're both no. If they're both equal to 1, then we do a swap cost, else infinity, because else you have one extra and that would be taken account. Flip cost. Okay. And then now, okay, so that's that. I have to do a prioritize swap, right? Let's run it real quick first. 1860. Okay, I mean it's good. We didn't do this one yet. Oh yeah, that's the one. That's what I was saying. We have to prioritize swap. Okay, so that's good. Okay, so that means that let's just say min is equal to min of SC, right? So then now we do swaps to this swap cost, right? And then leftover. That's fine, but and so extra is equal to this, right? So then now you have you have to swap, and then the extra ones. What are we doing about the extra ones? Extra ones, we either just do the flip cost. Or we do the swap thing trick. And you have one extra one which you can use for flip, I suppose. That should be good. I mean, those are the scenarios I'm thinking of, but it definitely can be wrong. Alright, let's YOLO. I'm probably wrong because this seems like really easy to be wrong. But yeah, this is a ridiculous problem. I mean, not really. It's just a lot of, it's very tricky case enumeration, and I probably could have written this in a way that is easier to debug. Instead, I wrote it in a way that if I had been wrong, it would be impossible to debug. But okay, let's Q4. Let's go. Thanks for watching, everybody. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.